I'm Allison, and I'm here today to talk to you about crafting performance alerting tools. This is the story about how Etsy went from having almost no performance monitoring, no automated monitoring, to having well-tuned alerts with context and tools to help us quickly investigate and respond to regressions. So, for a quick overview of how this is going to go, I'm going to talk to you a little bit about how things were before, tell you about how we went about adding monitoring, how we iterated on our alerts and our tools, where that's gotten us and what improvements and benefits we've seen from that, and what we're planning on doing to continue improving our alerts. And there will be some time at the end for questions. Just a note before I start, some of the terms that I'm going to be using are going to be specific to Etsy's stack, but the concepts that I'm talking about you can use across any stack, no matter what alerting tools you're using or what you're using to run your site. So, I'm a performance engineer at Etsy. Etsy is a global online marketplace for handmade goods, vintage goods, and crafting supplies, which is great because I like to craft, as you might notice. So at the performance team, at Etsy, the performance team is responsible for tracking our performance, understanding how changes that we're making to the site might impact performance, and helping empower other teams to own their product's performance. So you might have heard about Etsy that we really like to track things. We graph everything. The saying that we have goes, if it moves, we'll track it. If it doesn't move, we'll track it anyway, just in case it decides to make a run for it. So we've been graphing our performance at Etsy for a really long time. Today I'm going to be talking to you about our backend alerting, so I'll give you a bit of an overview of how we track our backend performance. Tracking performance, we use PHP on the backend. So as soon as Apache hands the request off to PHP, we'll start a timer. This timer will run through the entire life cycle of the PHP request until PHP stops running in the shutdown function. And that function will get the timer and throw that time into our weblogs. The weblogs are then processed by a tool called Logster. Logster is a system that will go through your logs and parse them, bringing out specific metrics that you tell it to pay attention to. You can configure this for a number of different metrics. For us, we're interested in that PHP time metric. So once Logster parses that out, it's going to keep doing that for a set amount of time, say 10 seconds. And then for all of those metrics that it sees in that amount of time, it'll aggregate them. So we have aggregations here that we keep track of the number of hits that we saw, the average performance, backend performance for those hits, the median, and 95th percentile. After that, we send it to Graph8, and you can see here a Graph8 graph of one of our pages' performance. At the top, we see the 95th percentile time, which gives us an idea of how our slower requests are performing. And at the bottom, we see the median time, which is an idea of a kind of middle-of-the-road performance. So now that we have these beautiful graphs, we can add them to our dashboards. This is an example of the performance graphs that we have on Etsy's deploy dashboard. The deploy dashboard is a collection of graphs that we think is important for people who are changing the site, pushing code to the site, to look at, to get an idea of how their changes have impacted the site, whether it be performance, errors that our users are seeing, business metrics, just good things for them to know. You'll see on these graphs a lot of vertical lines. Each of those lines represents a different code push. The different colors are different types of deploys. So if we look at this performance graph in the middle, you see maybe the homepage performance seems to spike a little bit. Somebody who's pushing code can look at that, see that there's a line to the left of it representing a web deploy, and say, well, probably that was caused by something that went out in that deploy. So this is great. We have the performance of these pages on our deploy dashboard so that everybody who's pushing code can see it, so that if they're pushing a regression, they'll notice and maybe do something to fix it. But there are a couple of issues with this. First, there are only 5 pages, as you'll see in these graphs. We have a lot more than 5 pages. But we have so many pages that we couldn't fit them all into these graphs. It would just be confusing and not useful. Additionally, like I said, we like to graph everything. So this dashboard actually has many, many graphs on it. People who are pushing code don't have time to carefully look at all of those graphs and see how their changes are affecting every part of the site. So changes were going out that had regressions on them, and nobody was noticing. The performance team might be looking at a graph later, like weeks to months later, and see a regression that happened, But by then, it was really hard to track down what had happened on that day and figure out what had caused that regression. We needed monitoring to help us understand what was going on our site and when our page's performance changed. So we started taking a first stab at this by writing some queries. Here's an example of one of our first monitoring queries, the slowest 5 pages report, and it's exactly what it sounds like. We would get this email once a week, and it was a list of the slowest 5 pages by median and 95th percentile on the site that week. And you can see here we have the name of the pages and the time that it took on the median or 95th percentile to load those pages in the backend. So this is cool. We know which pages are slow. That's great. But there are a couple of issues with this. It's not very actionable. If a page is slow, it's likely going to show up on this report every single week. So that doesn't actually give us a lot of new information. Additionally, maybe we don't care about the slowest pages. In fact, I would argue that we probably cared more about the faster pages, the pages that we had optimized because we knew that they were important. And we weren't getting any insight into those pages. And also, this didn't do anything to help us find regressions on our site. It's just the same 5 pages. If a slow page or if a faster page regresses, we won't know about it. So we tried again. This is our second attempt. This one's actually a regressions report, so that's cool. The way that this worked is that every night, this query would run. For each page on Etsy, it would look at that page's performance over the previous 24 hours, and then compare that to the page's performance in the 7 days leading up to that. If the performance in the past day was significantly slower than it had been in the previous week, it would show up on this report. So now we know that these pages have regressed, and we get some information about how severe those regressions were. But this also wasn't perfect. There were some problems with it. First, because of the way that the query was structured, it didn't catch any small or slow creep regressions. This is because if your page is slowing down little by little each day, then the historical data that you're looking at to see whether it's regressed is also getting slower just a little bit every day. So those will slip through. It was difficult to tune. This was a report that ran and looked at all of our pages. But as I've said before, we have a lot of pages, and many of those pages have different traffic patterns and different responses to that traffic. So we were getting a lot of false alarms. We were getting a lot of alerts that came in, and they had just been caused by a spike in that page that was maybe something that we could consider normal, and we didn't have to do anything. In addition to having to investigate to determine whether an alert was a real alert, we had to do a lot of investigation to find out what might have gone wrong. This required a lot of work on the performance team and took up a lot of our time. These last 2 bullet points combined were leading to alert fatigue on our team. We were getting a lot of alerts. They weren't all real alerts. And no matter whether they were real or not, we had to spend a lot of time looking into them. So this wasn't an ideal situation. What could we do? Well, we could enforce better graph watching during deploys. We could make sure that every time you pushed code, you pulled up the performance dashboard with all of the performance graphs for all of the pages and made sure none of them got slower. We could change the alerting mechanism, maybe find a different way to run that query, different query, so that we're having better tuned alerts. We could change the tools, create more tools to help us investigate the regressions once we got reports. Or maybe we could change the alert format to help us investigate and understand a regression more quickly. We ended up doing the bottom 3. Not surprisingly, we didn't do the first one. We decided that that wasn't good for morale. Additionally, it was prone to human error. So if you have to look at 40 or 50 different graphs, in addition to that deploy dashboard, all the graphs on there, you're going to miss a lot of things. So first, we worked on changing the alerting mechanism. To do this, we started using a system called Nagios. Nagios is a system that can monitor many different kinds of services. It was used already broadly throughout Etsy. This is because at Etsy, each team is responsible for monitoring their own products. So many different teams were using Nagios to monitor the products that they were in charge of. So with Nagios, you're able to get fast and fine-tuned alerting. This is because you can write your own service checks for whatever service, so that you can really be confident that when a Nagios alert is triggered, something's wrong. For us, we use the check graphite data script, a script that we've open sourced at Etsy. You can find it on our GitHub page. The check graphite script basically is given a URL to a graphite graph, looks at the raw data, and checks to see whether it's over certain thresholds that you have provided Nagios with. And if it's over those thresholds, it'll throw off an alert. So with Nagios, you have an individual check for each service that you want to monitor. And in the case of monitoring your page's performance, that means that you need individual thresholds for each page that you want to monitor. Now, at Etsy, I've said it before, we have a lot of pages, more than 5. We've got 40 pages. How do you choose well-tuned thresholds for 40 pages? I can tell you, you don't do it manually. I tried to do it manually, and I think I was going crazy by like the 3rd or 4th page. We built a tool. So this is called the PerfNag tool. It's a really simple first stab at a tool to help us make the process of creating new alert thresholds really easy. So let's take a closer look. You can see at the center, we have this graphite graph. This is a graph of the 95th percentile performance of the homepage. And you can see these 2 lines on that graph represent recommended thresholds. These thresholds were picked out, generated automatically by the script that's creating this tool. The math to do this is really simple. Basically, we know that for an alert, we want to be alerted when a page is above its normal operating time. So we wanted our alert thresholds to be a little bit above that too. So we took the 95th percentile over a week to kind of account for weekly seasonality in our page's performance. And we multiplied it by 1.1. Thought that maybe that was a good ballpark for an alert. And that was the warning threshold. We added a little bit of time on top of that, and that's your critical threshold. A human, of course, would have to go through and check these alerts to make sure that they were sane, because that's not very solid math. So we have these controls down here. When you adjusted the numbers in these controls, the graph would change to represent those new alerting thresholds. We also had some controls to change the window of the graph, the time window, the y-axis. And then when you were done, you could press one button that would copy the Nagios configuration so you could paste it and easily deploy. So let's take a look at this tool in action. We have to adjust the Y limit because the spike is throwing the initial limits off. Okay, so these recommended thresholds are obviously wrong. We'll bump it up, zoom in to make sure that we're picking something good when you look closely. Looks like we need to move that warning threshold up a little bit more. And now that we have a good warning threshold, we'll make the critical threshold just a little bit above that. And we're done. Press the copy button. Bam, new alert. All right, so let's take a closer look at that Nagios configuration. A lot of this I'm not going to go through because you can find it online. The documentation on Nagios' website is actually very helpful, and it's how I learned all of this. You can see the check command is running the check graphite data script to check the graphite data of that URL, which is the graph of that page that we're checking. And you can see the warning and critical thresholds in there. The check interval is the number of minutes that go by between Nagios checks when a service is in a normal state. When a service is in a non-OK state, in a warning or critical state, then Nagios looks at these 2 other parameters, the retry interval and the max check attempts. The retry interval is the number of minutes that go by between checks on a service when the service is not OK. The max check attempts is the number of times that Nagios will check a service before it alerts you that there's a problem. These ended up being really important for us in tuning our alerts because some of our pages have spikes. And for some of our pages, this is like a kind of normal thing. We don't want to be woken up, look at, well, which we aren't because we don't get emails, but thinking ahead, or sorry, we only get email alerts, not paged. But thinking ahead, we don't want to have to deal with those alerts if it's just going to go back down in 2 more minutes. So we adjusted those 2 parameters to make sure that we wouldn't be alerted on spikes. Finally, I'm also going to just call out this notification interval. This is the amount of time that goes, that passes between subsequent alerts that Nagios sends to you. Initially, this was set to something really low so that we would get an email about a regression, start looking into that regression, And then by the time we had kind of figured out what was going on, we would go back to our inboxes and have 4 more alerts on the same page being slow, which just wasn't great. We like clean inboxes, or at least I do. So now it's set to 1 day, which is really, we only need to be notified once in this case, because then we'll know that something's wrong. So creating this tool to help us visualize our page's performance and the alerts that we were creating helped us create really well-tuned alerts. So we started getting alerts in our inboxes, and we trusted them. Let's take a look at one of those. I get an alert. This is the first thing I see, the subject of the email in my inbox. OK, capitalized letters must be important. It's a problem. It's a warning problem. OK, warning problem. I guess I'll open it. Oh, big red letters now. Warning. We have how long it's been a problem for. Warning again. Some other information that I don't really know what that means. Looking up, I'll see that it's the homepage performance, and then my eyes are drawn down again to the capitalized letters. It's a site impacting problem. So it's good that I open that email, I guess. But where is the important information that's on this page? It's right here. The most important information in this email is the current performance of the service that's down, and where we would normally expect that service to be performing based on its warning and critical thresholds. Just looking at this email, with my eyes drawn to the big capitalized and colored letters, this is the last thing that I would read. So we weren't getting a lot out of these alerts. We needed to format our alerts to help us understand more easily what was going on. So we changed the alert format. To do this, we used a tool called Nagios Herald. Nagios Herald is a tool that you can use to add context to your alerts. It's on GitHub, or Etsy's GitHub repo, and you can also find more information about this in previous talks that other people at Etsy have done. Just a quick overview of how Nagios Herald works. Basically, for any kind of Nagios alert that you might receive, whether it be an email alert or a page alert, you can write your own formatter that will take the information that Nagios gives you about what's going on with that service and add context to help whoever's receiving the alert understand more quickly what's going on. So we took a first stab at this. Let's see, the title, Home Performance is at Warning Levels. The first thing I see very succinctly describes to me what's going on. So I'll open the email. The first line provides a lot more information, and it's bigger than the rest of the text, so that my eyes are drawn to it. I know which page is doing poorly, what its current performance is, and how high above the thresholds that is. My favorite thing about this is, of course, these graphs. This is a 24-hour graph and an hour graph of the performance of the page in question, so that I can really quickly see exactly what's going on. This is great, but as we were getting these alerts, there were still questions that we were asking that could really easily be answered with more context. So we tried again. Here's another version. You can see here, we've added those same warning and critical threshold lines that you saw in the tool that we used to create these alerts, so that you can instantly see, looking at this graph, where the page is performing based on where we expect it to be. We also have a link to that tool, so that if somebody needs to investigate further, maybe look at the page for a longer time window, or maybe zoom in, look at something smaller, then they can easily do that. This down here is really neat. At Etsy, we do a lot of A/B testing, and we ramp up big features through our A/B testing framework. Having a list of features that were ramped up or down in the past hour or so is really useful to help us know what might have caused the regression immediately just by reading this email. So this is great for general alerts, general context for all of our pages. But for some of our pages, there are specific pieces of context that apply just to those pages that are very important in helping us understand what's going on. This is an example of one of those pages. On our cart pages, we use a third-party payment processor to process payments for us. And sometimes that gets slow. It happens. And when that gets slow, our cart pages are going to get slow as well, because they're calling out to that on the back end. So we've added this context of how that payment processor is doing. You can see here that we have the performance of that payment processor in a couple of different aggregations. And we also have errors that we've gotten back from that processor in the past 4 hours, I think, which will correspond with the time range of that upper left graph of the page's performance. So obviously, looking at this, these line up pretty well. we can probably safely say that this is a problem with the payments processor. Now, the performance team isn't responsible for making sure that the payments processor is running fine, working with that third party when the payments processor is down and responding to that. The payments team is responsible for that. So we would probably look at this and just not do anything. We would like mark it as red, be done, maybe tell our teammates, hey, it's no big deal. But if we actually don't need to respond to this, why are we being alerted on it in the first place? We were able to set up Nagios service dependencies so that we now only get alerted when there is a problem that the performance team can respond to. Nagios service dependencies are a way of telling Nagios which services depend on other services. So in this specific case, we're saying we have this cart page and it depends on this payment processor. If the payment processor is doing poorly, then I know that the cart page is doing poorly, but I'm not going to be able to do anything about it. So if the payment processor isn't doing well, don't bother alerting me on the cart page. That's really cut down on the number of inactionable alerts that we get on our team, and we're excited to adding more things like this for more pages. So now we've done, let's see, we have gotten really well-tuned alerts. We've added context to these alerts to help us understand, looking at those alerts, what's going on. The next step in receiving an alert and responding to it is doing some investigation to help us figure out what might have happened. So naturally, the next step for us in iterating on our alerting structure was to improve our sleuthing tools. Remember this PerfNag dashboard from before? We gave it some steroids. Great for your dashboards, not good for you, PSA. So we've added a couple of things here. You can see at the top, we have the percentage of page views that this particular page gets compared to the rest of Etsy. This is helpful because maybe if a page that doesn't get a lot of traffic has a small regression, it's not something that's very important to us. So we can use this to decide where to put our time. We also have a link out to the Nagios page for this service so that somebody responding to alert can either respond on Nagios or take a look and see what's going on through that interface. Down here, we also have some controls to change the graph, the information that's displayed in that graph above. The users dropdown is really neat. This is a way of choosing whether to display performance of the page for all users, only signed in users, or only signed out users, maybe both. This is important because some regressions might only impact signed in users, for instance. Maybe it's some kind of personalization feature that we launched that's making the page slower just for those users. So that helps you understand what might be causing the regression. Similarly, we have this median and 95th percentile toggle down here. That does the same thing. A performance regression that is only in the 95th percentile might be caused by something different than something that you see in both the 95th percentile and the median performance. So that's really useful. Now, this tool wasn't a standalone tool for each of our pages. It was actually on a dashboard with all the pages we were monitoring. When a page was in a warning state or a critical state, we pull it up to the top and we change the background color of the tool for that page. So here it's the login view page is in a warning state, so we color it orange. This way, somebody looking at this dashboard can instantly see which pages are doing well and which pages are doing poorly. So we really easily get an idea of how our site is doing overall. Adding this context and working on these tools led to easier and faster investigation when we were looking into our reports. We were able to quickly get a general idea of how the page was performing, what was going on, dig in with a PerfNag tool, maybe change some of those toggles, see which users it was affecting. And then we could copy those graphs, paste them into IRC, and start talking with our teammates. But when I copy and paste a graph, I have to use my mouse, and I like to just use my keyboard all the time. So there's a way that I can still improve on this workflow. We have an IRC bot called IRC Cat. It's aptly named because we mostly use it to look at cat GIFs. But so here is the new command for the IRC Cat bot that we have. I'm saying, please show me the PerfNag graph of this page in the past 80 days. And there it is. This page got faster, so that's awesome. We use this to talk with our teammates about graphs that we found that were neat, graphs that had regressions. We were also able to use this to discuss regressions with people who were hanging out in the performance channel from other teams. So here we've gotten alerted on this page that had a regression. Just paste that into the channel, use the ircbot command to pull that into the channel, and I'm saying, hey Gio, who's on the team that's responsible for that page, do you know what might have been happening here? Could it be related to this? And he's like, oh yeah, probably, I'll file a ticket. So there we're really easily able to quickly get to the bottom of what's probably going on this page. As we were using this tool in the performance channel, other people started noticing. Here, Spike is learning about the PerfNag tool. As other people from different teams started learning about the tool, they started bringing it to other channels. So here you see in the payments channel, completely different team, that the people in this channel are learning how to use this tool to find graphs to own their own performance. Having these tools, the improved context in the email and the IRC command, improved our cross-team collaboration. Being able to really, really quickly start those conversations with other teams, either by pulling up a graph in IRC or by forwarding an alert to an entire team that had all of the context that we had, made it a lot easier to start investigating with other teams. So we have now created well-tuned alerts. We have added context to our alerts, and we have created tools to help us investigate our alerts. What's next? There are a couple of things that we're pretty excited about. First, alerting on improvements and not only regressions. At Etsy, we love to celebrate performance and performance wins. This is an example of our Performance Hero dashboard. This dashboard sits downstairs by the performance team and by all of the product teams. And it celebrates people who have worked to get performance wins throughout the site. If we were able to automatically be alerted on performance improvements, then we would be able to celebrate so much more, and that would be great. We would also be able to keep better track of where we expect our pages to be. If a page gets a significant performance improvement, then we can bring the thresholds down so that we know if it regresses again because we'll be alerted. There's more context that I think would be really great to have in our emails. We could maybe automatically find out which teams were responsible for the page that was regressed, the teams that we might be able to contact to find out more. Having that context in the email would make that step a lot easier. Maybe we could even automatically CC the teams in that email so that they could instantly start working on that problem. A list of recent commits that were made to those pages, maybe not ramped up in an experiment, would be very, very helpful. So you could really see what might have changed on that page and what might be causing the regression. A history of the alerts for that page would be really amazing. So we get a good number of these each week. So we investigate, see what's going on, and then maybe the next week we get alerted on one of the same pages again. It's really tough to keep track of what happened on which page. So having that available as context in the email would be great. We could have some better alert integration. Right now, we're getting alerted by email, and then we'll probably take the conversation to IRC. But we don't have to do that step. We could be alerted in IRC automatically. If we're doing that, we could automatically ping deployers, people who had pushed code recently, who might have pushed out that regression, and then they could just start right away helping us figure out what was going on. Finally, we're planning on moving these alerting tools and alerting contexts to other parts of our site. Right now, this is a great setup for the back end, but we would love to see the same context and tools applied in the front end, in tracking our mobile performance, and in tracking our API performance. So the takeaway from this, use context to improve your alerts if you have them, and to improve your tools. This has been really great in helping us cut down the response time, the time that it takes to resolve an issue and start working on an issue, and really great in bringing teams together to help us do that. If you're unsure of where to start, just think of the questions that you're asking yourself every day when something like this comes up. Which question do you ask every day? How do you answer that question? Can you do it automatically? And then once you've answered that question, what's the next question that you're asking? Building up in small ways like this is how we have arrived at the tools and the context that we have in our alerts today, and it's really great. So take it back with you. That's all I have. There's, I think, 10 minutes or so for questions. I'm also going to be posting these slides later. I'll link to them on Twitter, so check that out if you're interested. That's it. Yes?
So how often do you set those thresholds? And then when you change them, do you track historically what the thresholds were? And like you showed that sort of 80-day chart, so how do you know if that changed?
Yeah, that's a good question. The question was, how often do you change the thresholds for those alerts? And when you change them, do you track the changes that you've made? We don't change them very, very often. Because, I mean, ideally, if a regression happens, if the page goes above the alerting thresholds, we would like to make it faster again. So that's the goal. But in some cases, that's not actually the best response. For example, somebody's ramping up a feature that makes the backend a little bit slower, but is a conversion win. Then we'll want to keep that, and we'll change the thresholds to adjust for that. We don't actually track in any automated or integrated way what the thresholds were and what they've been changed to. We have that information in the Git logs, and I think only one time have I been curious enough to go back. But it is good information to have, and you were mentioning in the 80-day graph, that's not the thresholds that are shown there are the current thresholds and not historic thresholds. So that's something good to think about. Yes?
How far back does your time series data go, and what kind of data mod do you use to offload that?
The question was, how far back does your time series data go? And I'm sorry, what was the second part?
What kind of a storage mechanism do you have for?
Okay. And what kind of a storage mechanism do you have for doing that? I'm not entirely sure how far back our performance data goes. This is actually something that is different between all of our graphs. Graphite has something called retention schemas that let you configure for how long and how it stores data. Basically, you give it a granularity and an amount of time, and you can give it a number of those. So say maybe we have 1 minute data for, I don't know, a month, 2 months, and then we roll it up into minutely. Oh no, that was the first one. 10-minute data for a while, and then 10 year. We keep things around for 10 years. That's a long time. Okay, so that's like as old as Etsy is. So we're going to start soon losing our first pieces of time series data. In the back-ish. I'm sorry, how does the APM application performance management solutions fit into the alerting and logging? And do the teams who are actually troubleshooting the alerts look to you for the deeper dive data, or is that? I'm actually not familiar with what you're talking about. APM? Application performance management solutions. Yeah, I'm not familiar with that. I can tell you about how the different teams who are responsible for the pages interact with the performance team. It kind of depends on what the issue is. A lot of times we'll get alerted about an issue and do enough digging to figure out who we should be talking to next, and maybe get some hints. Like sometimes it's really obvious which commits might have caused a regression. So we'll be like, hey, we found this regression. It looks like it's this. But a lot of times it's a lot of collaboration until the point where we know what the problem is, and then the teams themselves are mostly responsible for going in and fixing those problems. They're using actual application logs? So it depends on what the issue is. We'll look at the graphite graphs for a start to like narrow down when the issue started. And then depending on what kind of issue it is, I'm sure that teams will look at different logs and such to figure out how to fix it. Yes?
I had almost the same question that you did. I'll phrase it a little differently, and then a really good question. So I'm just trying to make sure that, so APM, there's a lot of very fancy, expensive tools to do that. It sounds like you guys are purely using Nagios with your custom checksing graphite in place of some big fancy thing.
Yeah, I guess so.
This is super cool. My other question was, how come you're only sending alerts to like your chat ops and email and not like pages or push notifications?
That's a good question. Yeah, the question is, why are we only sending alerts to us in ways that won't wake us up, basically? That's because most of the performance issues that we're going to end up being responsible for are going to happen during the day while people are deploying code. It's those changes that make the issues that we're going to go in and fix. If there's another performance issue that is like some machines having problems and slowing down a lot, other teams are responsible for those machines, so they'll be alerted on those. Does that answer your question? Cool. Any more? No? Once, twice? Yes?
Are you using Nagios Core or Enterprise?
Core. We're using Nagios Core. Yes?
We looked at adaptive thresholds and using something like coworkers to determine what the threshold should be.
Have we looked at adaptive thresholds using a tool to look at our graphs and determine what the thresholds should be? I thought about that initially when I started working on this problem and was a little bit scared of a machine just automatically updating all of our thresholds. So I moved away from that initially. I haven't looked at it again, but now that we have something set up that's really working for us, we might build on top of it in that way again.
Yeah, and in operations, we keep looking at full winters and saying, that's going to be great. And then we ground.
Okay.
Yeah, and there's actually there are modules for Nagios that will do the same thing, but it's just too noisy without the opportunity.
Any more questions? Yeah, they were talking about Holt Winters, which I think is a smoothing algorithm that you can use, and maybe it comes for free with Graphite. There are Nagios plugins that do that. The one that we're using actually does that, but we just do a really simple look at the past average. Holt Winters is too noisy, is the consensus. Okay. Oh, one more. Yes?
Can you tell us something where something went completely south?
Tell a story about where something went completely south.
Right.
I'm not sure that I have a great example in terms of what I talked about today, just because it's not been around for a very long time. Most of not the original queries that I was talking about in the beginning, those were older, but the more recent stuff has been like the past 5 months we've been building on it. And I don't think we've gotten any horror stories yet, but I'll update you. I'll give you an update if we do. Okay, thank you.